button to...
So you could use calculator.
Yeah.
So that'll be, let's just, you could do calculator. These you could do with calculator. And there's a reason why, is because you kind of see where it all comes from. You've got 4 different quadrants. So an angle, if it was starting out to the right and then opening up in this direction,
Yeah.
then this would be like the first quadrant is like the first, quarter, then second quarter, third and fourth. The signs of sine, cos and tan in the second quadrant. So if we go back to our graphs, so the second quadrant is between what and what? What 2 angles?
90 and 180.
Yeah. And so what is sine, between 90 and 180, is sine x positive or negative? What about cos x? What about tan x?
No, I don't know. Not too sure.
So 90 to 180 is here on the sine graph. That's 90. That's 180.
Okay.
What is the sine? What the y coordinate? Is that positive or negative?
Positive.
Yep. And so in the second quadrant, sine is positive. How about cos? It's turned sideways between 90 and 180.
Is that negative? Mostly?
Yep. And the tan graph looks like that. And let's see, this here is the 90 degrees, I believe. And so 90 to 180, what is tan?
Zero? Or
Like from 90 to 180. Is it positive?
negative?
Yes.
Okay.
And so only sine is positive in the second quadrant, meaning from 90 to 180. Only sine is positive. You could do the same with all the others. All 3 are positive in the first quadrant. Only sine is positive in the second. Only tan is positive in the third. Only cos is positive in the fourth. And
Okay.
so all 3 are positive from 0 to 90. Only sine is positive 90 to 180. Only tan positive 180 to 270. Only cos is positive 270 to 360.
Okay.
And let's see. Okay, exact values. Just, you can use calculator, it'll just speed things up. So this one, this comes from the area of a circle in general. X squared plus y squared equals 1. In this case, like equals r squared. In this case, the radius is 1, and so it's like 1 squared, which is 1. What is the sine of theta in this one? And because it starts from 0, 0, the base is x, the height is y.
So what are you trying to figure out here?
Let's say sine theta, opposite over hypotenuse. What is that?
Opposite of... y over 1?
Yeah, and what is y divided by 1?
Y?
Yeah, and so sine theta is y. How about cos theta?
X over 1. So
Yep.
X.
X. And so square both of these, what do you get?
X squared and y squared.
And the other side?
cos theta squared.
Yeah.
Minus
Cos squared theta and
sine squared theta.
add them together. What do you get?
Not too sure.
You get sine squared theta plus cos squared theta is equal to y squared plus x squared. The equation shows us that x squared plus y squared is 1. And so that shows us that sine squared theta plus cos squared theta must be 1. So basically, sine squared anything plus cos squared anything is always 1.
Okay, but at the beginning you squared both of them. Why? Why did you do that?
Which two did I square?
Y and x, you squared them, and then you squared the other sides as well.
I did that because so this original equation is x squared plus y squared equals 1 squared. And so I squared both sides of the first one and squared both sides of the second one, so that when I added them together, I would get x squared plus y squared.
Okay.
And so I know x squared plus y squared is 1, and so I can replace x squared plus y squared with 1. And that shows that sine squared theta plus cos squared theta is 1.
Okay.
So using that, let's try this.
1 for the first one.
Yeah, let me just see something. This is file 0.42. Okay, sorry, 1 second. Yeah, I should be using this one. Forgot to upload it. It's alright. Yeah, you see, here it is, much easier. Sub into the theorem of Pythagoras. Okay. So we know sine squared theta plus cos squared theta is identical to 1. Okay, so that was 1. How about part B?
Is it 4 by any chance?
What is sine squared theta equal to if you rearrange this up here?
1 minus cos squared theta.
Yeah. And so factorize out 5. What do you get? Or actually, what if we made cos squared theta the subject? What would you get?
Uh, 1 minus sine squared.
Yeah. And in this one, factorize out 5. What do you get?
Minus sine squared theta.
1 minus sine squared theta.
Okay.
And simplify. What is that the same as?
5 cos squared theta.
Correct. 5 cos squared theta. Okay, question C.
Same, I don't know if that one.
Say it again.
I'm not too sure about this one either.
How about the bottom of it? What could you do there?
Square it.
What is 1 sine squared 2 theta the same as? It's very similar to the one before it.
Yeah, I'm trying to think about it, but sine.
No.
No. Yeah, it's the same. I don't know for this one.
What if it was 1 minus sine squared theta instead of 2 theta? What would it be? in your previous one, 1 minus sine squared theta. What did you turn it into?
Cos squared theta.
Yeah. And so this one?
So it's cos squared 2 theta.
Correct. So that is 2 theta over the square root of cos squared 2 theta. What can you do next?
The 2's cancel out by any chance? Probably not.
Squared and square root.
Sorry?
You have squared and square root.
Oh, do you get cos 2 theta?
Yeah, those two cancel each other out. And so you're left with sine 2 theta over cos 2 theta. Any idea what is sine over cos?
No.
It is tan 2 theta. And so instead of having two different things, you now have just one thing, tan 2 theta. For the previous one, you have two different things, 5 minus 5 sine squared theta. It's now just 5 cos squared theta.
Do the 2 thetas not cancel out?
It's the sine of 2 theta, so it's not times 2 theta. So it's like they're in a bracket. It's like square root of 2 theta or something. It's if it was times, then over means divide, times divide. They would cancel each other out because they're the opposite. Whereas this is the sine of 2 theta. We just don't write in the brackets, but it's a different operation. Right, we'll practice this stuff. Okay, let's try it.
I don't know either.
Tan theta. What is tan theta the same as?
Sine theta over cos theta.
Yeah. And so what would you have to do to both sides to get sine theta over cos theta?
Divide by each other.
Basically divide everything by cos theta. Divide both sides by cos theta. That'll get you sine over cos.
Tan theta.
Yeah.
Equals 6.
Yeah. Tan theta equals 6. Great. Question B.
Okay. So is cos divided by tan sine?
Sine divided by
Tan.
cos is tan, but part B uses sine squared and cos squared.
Okay. Are they both equal to 1?
No. Sine squared theta plus cos squared theta equals 1. We want it in terms of sine theta, so we want to get rid of cos theta. What is cos theta the same as?
Sine theta.
Just rearrange.
Cos squared equals theta. I'm confused, sorry.
So you did it earlier. 1 minus sine squared theta.
Okay.
And okay, So we want to eliminate cos squared theta from this. We want only sine. How do we do that?
So 4 1 sine squared theta now on one side.
4 times 1 minus sine squared theta.
Minus 5 sine squared theta.
Yeah. And
So then
simplify.
So 4 minus 4 sine squared theta. Minus 5 sine squared theta. Minus, so is it now 4 minus 9 sine squared theta?
Yeah. And that's sine squared. We want just sine. It's very difficult to see anything else you can do. You probably, what if I did this one? 4 minus 9x squared. Any idea how you could factorize that into 2 brackets?
No.
That would be difference of 2 squares. 2 minus 3x, 2 plus 3x. So like square root of both. 1 is plus, 1 is minus. Can you use something similar for this one?
The difference of 2 squares, wait, I've completely forgotten that compared to GCSE. Or was it beginning of the, I don't know. Okay, so for this one then it's 2 minus 3 sine squared theta.
Just sine theta. Oops. And the other one?
Yeah, 2 plus 3 sine theta.
Well done. Let's see. So do this one. You want tan, divide everything by cos. So get sine over cos. And if you want to eliminate cos squared, you replace it with 1 minus sine squared. Just rearrange that. Let's see. So very difficult. Very difficult. 1 second. Better do it. Tell you what. No, do we? Let's do it. Okay. Any idea how we do this one?
So we want to get tan on the in the fraction.
Yeah. We have an algebraic fraction, so what I'd recommend is you fully factorize the top and bottom and then simplify from there. So let's say the bottom, anything you can factorize.
Cos?
Yeah, cos x. What do you get?
1 minus sine x.
Hang on. Not 1. Cos x times what gives you cos squared x?
Cos x.
Yeah.
Okay.
Any idea how you factorize the top?
You have to get sine squared x to become cos. So the 1 minus.
Let me think. It might work. It's difference of 2 squares. Something squared minus something squared.
I can't remember.
We can do it the other way then. So let's say cos squared x. We'll replace the. Nah, it's easier. X squared minus y squared. Let's say x squared minus 9. What is that difference of two squares?
I can't remember.
That is x plus 3 and x minus 3.
How do you do that?
So it's basically the same as like x squared plus 0x minus 9. You need two numbers that multiply to make minus 9 and add to make 0. And so 3 and minus 3 will work. But you can just I just recognize it, that it's something squared minus something else squared. So that's like x squared minus 3 squared. Because 9 is 3 squared. And
so is this just factorization, basically?
Yep.
Okay.
And so same thing for the top one.
So when you say difference of two squares, it's just factorization, or is something more to that?
It's a special type of factorizing.
Yeah,
like an easier type.
So is it cos? Is it cos in the bracket?
Yeah, cos x.
And is it cos x in the other one as well, or is it sin x?
So
Okay.
you can see here, x squared, it's the square root of one and then square root of the other. One is plus, one is minus.
Sin x and then sin x, okay.
Yeah. And how can you simplify that fraction?
Cancel out both brackets.
Yep. Okay. What do we
Then
have?
Cos x plus sin x over cos x.
Yep. Any idea what you do next?
No.
Oh. So you can distribute this out. Let me just show you. What is 2 over 7 plus 3 over 7?
5 over 7.
So you can now do that automatically. Once upon a time, you had to bring the two together and copy the denominator. If you can bring the two together, you can bring them apart again. So using that, 2 plus 3 over 7 is the same as 2 over 7 plus 3 over 7.
Okay, so it's cos x over cos x plus sin x over cos x.
Yeah, and simplify.
One over cos x?
Well, cos x over cos x is 1.
Okay. So I thought cos x plus sin x was 1. Or is that cos squared?
Squared.
Okay. 1 plus sin x over cos x.
What is sine over cos?
Tan.
Yep.
Okay, so tan x.
And that's what we needed. So we have this complicated thing, and we simplified it down to 1 plus tan x by fully factorizing the top, fully factorizing the bottom, cancelling down, and then you distribute it. Difference of two squares is difficult. Factorizing the bottom is kind of normal. Difference of two squares, it's just difficult to see with trig. And this might be the most challenging stuff. Okay, any idea? Let's see. X to the 4 minus y to the 4. Any idea how you do difference of two squares with that?
No.
What is the square root of x to the 4?
x squared.
Yep. And so, what would that be?
Then minus x squared plus x squared.
So we have x squared plus
y
minus...
squared. Y squared, sorry.
Yeah, y squared. So can you use that to factorize this fraction?
Cos squared theta
Mm-hmm.
minus sine squared theta cos squared theta plus squared theta.
Mm-hmm.
Over cos squared theta.
Yep. Any idea what's next?
No.
Notice anything about the second bracket?
That's equal to 1. Okay.
That's equal to 1. And 1 times the first bracket is just the first bracket. Whoops. So we now have cos squared theta minus sine squared theta over cos squared theta.
Yep.
What is next?
Cos squared theta over cos squared theta
Great, yep.
minus sine squared theta over cos squared theta.
Yep. What do you get?
1 minus tan squared theta.
Which is what we were supposed to get. Well done. Difference of two squares in disguise, because x to the 4 is x squared squared.
So is difference of two squares always just with two components? So x and y, for example, or is there sometimes a third one?
No, then that would be just normal factorizing a quadratic.
Okay.
Yeah. Okay. Let me see this one. All right. How about this?
Okay, so 3 sine squared x. That can be written as 1 minus 3 cos squared x.
So we replace sine squared x with 1 minus cos squared x.
Okay. And then from there, you get 4 cos squared x minus 3 plus cos squared x.
Something's missing.
3 cos squared x.
Yep.
And then, so 7 cos squared x minus 3, then plus 3 on both sides.
Yep.
Gives you what you want. 7 cos squared x equals 5.
Great. And let's try this.
Okay, so for 12 cos theta, actually no, probably best to leave it as
Yeah.
4, 3 cos, is it squared theta because it's 4p squared?
Like we'll get there.
Okay. Plus 9 2 sine theta squared equals 36. And then, do we have to square them first? So 4 open brackets, 9 cos squared theta, 9 4 sine squared theta, 36, both of them 36 cos squared theta, and then sine squared theta. And then is cos squared and sine squared 1.
Factorize. What's common factor? Common factor?
Sorry? 6 in both of them.
And they have a much more obvious number in common.
36?
Yeah.
Oh, okay. Cos squared theta plus sine squared theta.
Yes. And now you can replace it with 1.
Okay.
Because it's, yeah. And that is 36. Great. So you had to show that it was identical to 36. Yeah, just sub it in. Okay, let's see. That's trig identities. This stuff we saw earlier. A little bit. Okay, now we need to do this. We need to find, so cos theta is minus 3 over 5. We need to find sine theta. How do we do that?
Is cos theta 1 minus sine theta?
Well, cos squared theta is.
Okay, so square both of them. Cos squared theta, and then squaring the fraction is minus 9 over 25.
Yeah. What's a minus times a minus?
Okay, so 9 over 25.
Yeah. You're right. And that is the same as 1 minus sine squared theta. Right. We want sine theta.
Plus 1 on both sides.
Yep.
So...
Well, on the minus 1 on both sides?
Sorry?
Minus 1 both sides?
Oh, yeah, sorry. So... Minus 16 over 25.
Yep. You can always use calculator.
And then do we switch both of them sides so they both become positive?
Yeah. Times both sides by minus 1.
Yeah. And is that what we wanted?
Well,
16 over 25?
That's sine squared theta.
Oh, okay, so the root of that is 4 over 5.
So that is, well, it's plus or minus 4 over 5.
Okay.
However, it's a reflex angle. And so which quadrant is it in?
Reflex angle is about 180.
So reflex angle, yeah. So it's in between 180 and 360. And so it's in between, which quadrants is it in?
Negative one.
Well, it's either in the tan one or the cos one.
Okay.
We're told cos theta is a negative number, and so which quadrant is it?
Cos.
This is where cos is positive.
Oh, okay. Tan, sorry. Okay.
So we've narrowed it down. So we knew it was between 180 and 360. We now know it's between 180 and 270. And so in the tan quadrant, We have sine theta is plus or minus 4 over 5. Which one is it? Positive or negative sine theta?
Negative.
Yeah.
Okay.
Only tan is positive in there. This is like a big plus sign. And so the answer is sine theta is equal to negative 4 over 5. In the same way that cos theta was negative 3 over 5 because it's only tan is positive in there.
Okay.
So very similar. Let's try question B.
Okay. Sine. What letter is that?
Alpha, they call it.
Okay. Sine alpha equals 205. So now I want to square it. So sine squared alpha is equals 4 over 25. One minus cos squared alpha equals 4 over 25 still. Minus 1 on both sides to get 21 over 25, minus 21 over 25.
Mm-hmm.
And then square root it.
Right.
Cos, so minus cos alpha.
Times both sides by minus 1. Make the most positive first.
Okay. So cos squared alpha equals 21 over 25.
Right.
And then cos alpha equals minus a root of 21 over 5.
Yeah. Over 5. And actually, you know, it was like x squared equals 9. You get plus or minus. Because we don't know. Like negative root 21 over 5 will also work.
Yeah.
So
Okay.
how do we know? Is it positive or negative?
So it says obtuse.
Mm-hmm.
So it's above, it's more than 360.
I think you're thinking of reflex.
Sorry, an obtuse angle is between 90 and 180.
Yeah.
Okay.
And so what quadrant is that?
Sine, where sine is positive.
Yeah. And sine alpha was positive.
So cos is negative here. So minus root of 21 over 5.
Well done. Great. And that goes back to the three diagrams for sine, cos, and tan. Like when is it, you know, the graphs, when is it positive, when is it negative? Minus root 21 over 5, minus 4 over 5. Grand. These are similar. You use the cos rule. Yeah. So this is, you use the cos rule or the sine rule. And then you just say is it positive or negative by checking at the end. And so that stuff, what do you give yourself?
Yeah, between a half and a tick, but I definitely need to practice. Probably rewatch this video.
Yeah, it's a very tricky one. So I have another student now, fortunately. If you want, we can try and do extra time on Friday.
Yeah, thank you.
Okay, so yeah, because I think it might be too late for you. Yeah, how was that for you, Hugo?
It was fun, yeah, but definitely need more practice.
Yeah, this is difficult, this trig stuff. Any questions from you in general?
No. Except, have we finished this chapter for today, or is there more stuff?
So this chapter is, the next stuff is very different. It's solving trig equations. It's not trig identities, but there's, you could always do whichever you want to do.
No, I just want to finish the chapter. I wanted to know how far in we were.
Yes,
okay.
we finished we did the first 3 sections, and then the next section is I think there's 2 more sections of solving trig, but it's quite challenging.
Okay. Alright, great. Right. Thank you.
All right, well done, Hugo. You did great. I look forward to talking to you on Friday.
Great, thank you. See you Friday.